Semiconductor technology or in electronic technology, what is important is to draw VI curves, voltage versus current curves, VI diagrams. We call the drawing characteristic curves, VI characteristic curves, because is the the VI diagram gives us, let us know, indicates us about the nature of the device, this VI diagram. Here you see, this is, we draw a VI diagram. How? It is a diode, symbolic symbol is diode symbol is there, it is positive, it is negative, its arrow means it is a variable, and there is a voltmeter there and current here. That means you apply some voltage and measure the current. Okay. And here you see the diode is in forward bias. Yes, positive side joined to positive side, and it is negative side to negative side. It is forward bias. So forward, how is the forward bias characteristics of diode? You see here. Here it is voltage, it is current graph. Yes, in your book you see. Yes, it is a voltage. Yes, you see initially there is no current, almost 0.2 volt, 0.4 volt, 0.6 volt. Nearly 0.6 volt, 0.6 volt, current starts and suddenly it gets increased. Suddenly it increases. A rapid increase, not straight line increase. We call it exponential increase. This suddenly increases. And this current is of the milliampere order. Yes, I milliampere order. Okay. And this voltage, where it suddenly rises, it is called cut-in voltage or threshold voltage. Cut-in voltage or threshold voltage. And here very small voltage I have told you for silicon it is 0.05 volt, electron volt minimum necessary, but for if you apply 0.05 electron volt, it will very some 1, 2, 3, some very small number, few electrons will move, and that will cannot be shown in this your millimeter. That you cannot be detected by your millimeter. They are current, but very few, so it shows almost zero. And when you go on increasing voltage, nearly 0.6 volt, it starts, and this knee, if you find knee here, is about 0.7 volt. 7 volt is applied, it gets rapidly increasing. It gets increasing rapidly. Okay, it is exponential increase. Okay. It is in forward bias. Whatever reverse bias, if you put reverse bias, it is microampere I have told you. Yes, these are due to minority carriers, very small currents, because they have favorable field. If forward bias, the majority carriers are favorable. The minority carriers, they are not favorable, but they move because due to barrier potential. Barrier potential is there, so they move slowly. Very small current is there. It is reverse bias. Forward bias, there is no minority carriers movement. Okay, it is majority carriers movement, but reverse bias, majority carriers will not move, but minority carriers have their favorable situation. But since their number are few, they produce current but with negligible magnitude, very small current is of microampere order. They move that way, and after some time they get sufficient energy to collide with themselves or tearing the bond, and suddenly current increases. Of course, in microampere order, it is knee voltage, it is your breakdown voltage. It is breakdown voltage. So, it is the forward characteristics. Here majority carriers have the role to play, and here the reverse characteristics, reverse bias characteristics. Here minority carriers have the role in current movement, in current flow. Minority carriers are responsible for current flow, and initially very small, and after breakdown, when breakdown condition is there, they is high. There is high. Okay, and these are called characteristics curves, VI diagrams. Okay. Now, yes, and there are resistance.